moving on to complex numbers. Kind of like when we have a mixed fraction. A mixed fraction is part whole and part fraction. Well, a complex number is going to be part real and part imaginary. So when I look at these, alright. Uh-oh, this pen's being wonky too. I might have to move over one. I don't know why certain parts of the room do not work right. Alright, here we go. Okay, there is a complex number. It doesn't look like numbers at all because it has a bunch of variables in there, correct? But if I were to say, okay, what's the imaginary part? Well, what indicates imaginary? The I. So right here, here's my imaginary part. And then therefore I have a real part, which obviously would be the other piece of my little expression. This is going to be the real part. Okay? So complex numbers are going to be real plus imaginary or real minus imaginary, hence is why I put a plus and a minus there. So what are we going to do with those? Well, I said we were going to get into adding, subtracting, multiplying. We won't really do division yet because we're tying it into our quadratic unit. So, for example, they might say find x and y. Oops, I didn't want a D. My mind seems to work a little goofily here. Given, and let's say they give us two complex numbers set equal. Let's say I have an x plus 3i equals, and then my other complex number is a 9 minus yi. Again, we have with our complex numbers a real part and an imaginary part, and the I is the indication of the imaginary part. So when they give us two complex numbers and they have that equals in between, it's saying take the real and set the real equal to real. So you're going to look and say, okay, what's my real part? And I'm going to set it equal to the other real part. Well, over here it's easier to see the real part. Which one's the real part over here? What's real? Which one doesn't have the I with it? The 9. Alright? So when I say real, I would say 9's a real number. Over here, which one doesn't have the I with it? Yeah. So here's real and real. We set them equal. Do we have to do any solving for x, or is x already done? It's already done. If it were to have a number in front of it, we might have to divide. Then I'm going to take and say, okay, I'm going to take my imaginary and set the imaginary equal to the other imaginary. The i's we don't take with it. The I is just an indication of the imaginary part. So if I look over here, my imaginary coefficient is what number? 3. So I'm going to take my 3 and set it equal to, so the I just indicates that that's the imaginary part. What am I taking from over here then? Yeah. And go ahead and take the plus or the minus with it, so it's really a negative y, correct? Do I have to do a little solving on that one? Yeah. What do I have to do to get y by itself? Divide. Yeah. And divide by a negative, since it's a negative y. So y really equals? -3. And that's all you have to do. If they give you a complex number equals another complex number, to find x or y, you simply just have to say real part equals real part. We didn't have to do any solving on that one. Imaginary coefficient equals the imaginary coefficient. We did have to do a little bit of solving, and we get our y. Those are complex equations because it's real plus imaginary or real minus imaginary. Let's look at one more of those. All right, let's say we have a 9 plus 4yi equals a 2x plus 3i. Again, once you look at it and say, oh, there's an equation, these are complex equal to a complex, we just set real equals real. So what are the real parts we're going to set equal? Very good. 9 equals 2x. Do I have to do any solving? Whoops, x. Do I have to do any solving for x on this one? Sure. What do we have to divide by? 2. So x equals 9 halves. I don't care. 4 1/2. Whatever you want to write it as. It is a 9 halves. If you want to say 4 1/2, 4.5, same answers, right? Either or, I don't care. Good x values. So real equals real. What's the imaginary parts we're going to put together? Excluding the I. 4y and 3. So looking at my imaginary and my imaginary, do we have to do any solving here? Yeah, we got to divide by what this time? 4. Again, I don't care if you leave it as a 3/4 or if you change it to a decimal. Some of us love to punch things into a calculator. 0.75, would that be correct? All right, so we just talked about complex numbers. If you have 2 of them equal, we take a real part equals a real part, and imaginary equals the imaginary. We might have to do a little bit of math to solve for x and y. Still with me? Not too bad, right? This section's not too bad. All right. We said we were going to add, subtract, multiply, and divide, right? I'm not going to divide, though, I said. That ties into a different unit. So we will see these again sometime. But we're going to add, subtract, and multiply. Again, if you were wanting to look at the book, they do have examples of this as well. All right. I like to look at the monitoring progress. What were the 2 important things we wanted to remember again out of this section? Square root of a -1 equals I, and then I squared equals -1. I don't know if that comes into play on all of these or some of these, or if it's just part of it. But it will probably come back. I think it's the I squared when we multiply, to be honest. All right, I've got a bunch of examples here. And so if I start with example 1, underneath this add, subtract, multiply, and divide, I do have an adding and subtracting first. So say I have a 9 minus I, complex number, plus a -6, hold on here, oopsie doopsie, plus 7i. They're in parentheses because they are complex numbers. We're just going to combine like terms. Combine like terms if we're adding or subtracting. So if I were to say, okay, here's a real part of 9, what does it get added with? -6. So when I look at 9 plus -6, it's really not adding. What are you going to do to get your answer? Yeah, so 9 minus 6 is 3. Real plus real. Then I'm going to look at the imaginary. I'm going to say -1 plus 7. So how many I do I have? -1I plus 7I is 6I. And we do want to keep the I because we're actually getting a complex answer to that addition problem. And that's your answer. Combining like terms. Real plus real. So 9 minus 6 gave us 3. -1I plus 7I. So imaginary plus imaginary gives me 6I. Combining like terms if we're adding or subtracting. Let's look at a second one. That's adding. Let's look at subtracting.
It's probably her favorite day.
I know, yeah.
I totally forgot.
She's not here though.
Yeah, but still.
Yeah, we'll
so,
send her a text.
Yeah.
Thank
Sorry for
you.
her.
All right, here's a subtracting. Now my suggestion on subtracting is to distribute the negative and then combine like terms. Again, my suggestion is distribute the negative and combine like terms. So if I distribute the negative to that second complex number, that 8 is now going to become what kind of 8? -8. That negative really makes that -2I become positive. That is my suggestion so that we don't forget that it subtracts that second term as well. So I like to distribute the negative and then combine our like terms. So once we distribute that negative, it made the 8 become negative. A -2I makes it be a +2I. And now we're looking at real and real, imaginary and imaginary. So if 3 is the real part, what's real here? -8. So that gives me an answer of what for the real part?
5. -5.
-5. Imaginary. Imaginary gives me how much imaginary?
+9.
Plus 9I. And that would be my answer. Alright? Adding and subtracting, and on subtracting, distribute the negative, less likely to make that error. Okay? Still pretty easy, right? Combining like terms? Alright, let's look at a third example. Alright, oh, here's a long line of stuff. Alright, looking at this long line of stuff, I have a real number subtracting a complex number, subtracting another complex number. So just because we're in a complex section doesn't mean we can't have a totally real number or a totally imaginary number with some complex numbers. But again, when we are subtracting, I do like to distribute. Distribute the negative. So when we go to that first parenthesis, and it's not a -4 times, it's just a -4 minus that complex number. So my 1 becomes what? -1. That negative distributed to the I makes the I become negative. I'm going to do the same thing with my second parenthesis there. Distributing a negative makes that 5 become -5. Negative to that 9I makes that 9I become -9I. Distribute your negative, then combine like terms. We still have that 4 out front. So when I look at, here's a real part. What are the other real parts? -1 and?
-5.
Yep. How much real do we really have when we combine all 3 of those? -10. Good math. And then if I look at imaginary, I just see 2. A negative 1i and a negative 9i really gives me how many I?
Negative 10.
Very good. Adding and subtracting. Combine like terms. My suggestion, distribute the negatives so that we don't get signs wrong in our answers. That's adding and subtracting. We said we were also going to do what? What did that heading say? Oh, we better multiply. So that's probably when an I squared might come back to say, oh, don't forget I squareds are negative ones. Whoops. All right, here we go. Example 4. Let's say I have a negative 3i times a 10i. Now those are both purely imaginary because they just have i's. All right? Still the same sort of thing's going to happen. We're going to multiply like we normally would. So when I think about multiplying this, I'm thinking about negative 3 times 10. And negative 3 times 10 is what?
30.
A negative 30. When I look at my I times this I, it's like I times I is x times x. What do you get? I squared. Again, noticing that the parentheses were butted up to one another, we didn't have a plus or a minus in between, so that is an indication of multiplying. And remember how I said, oh, we're probably going to see an I squared when we multiply? We do. I squared is really what number again? Negative 1. Negative 30 times negative 1 really gives me an answer of positive 30. And that would be our answer. Okay? Negative 3 times 10 is negative 30. I times I is I squared. That's one of our rules. I squared equals negative 1. Negative 1 times negative 30 is a positive 30. Still with me? Yep. I see a couple nodding of heads. All right, example 5. Let's say we have an I outside of a complex number. So I have an imaginary times a complex. What do you think we're going to do on this one? Yeah, distribute. Distribute I times 8. Distribute an I times a negative I. Well, there's that I squared again. What does I squared mean? Very good. Negative 1. But I already have a negative. So negative, negative, double negative makes it be?
Positive.
Positive 1. And I have an 8i. Now, whoever again invented these complex numbers, they always want it real plus or minus the imaginary. So not that this is wrong, but it would be more correct to start with the real part, and which one's real? The 8i or the 1? Very good. A 1 plus 8i would be more correct. It's not totally wrong, it just whoever invented it said real plus imaginary. Kind of like when we write our mixed numbers, it's the whole number and the fraction. Okay? Order does matter in certain situations. Still good? All right, example 6. We might have a complex number times a complex number. This is going to be a FOIL. Does everybody remember hearing those? Double distribution is what I like to call FOIL. But we start with that first term. So this 3. 3 times the first term of 5 is really what when we multiply?
15.
Whoops, 15 I heard, correct. 3 times my 2i, which are the outside terms, so 3 times a negative 2i is?
Negative 6.
Very good, 6i. Then I move to my inside terms, so moving to the I times my 5 is? 5i. And then we move to the last and the last, which is that I times a negative 2i.
It's a negative 2i. Okay.
And then, oh my gosh, there's some condensing down or combining like terms, and I squared. You can do both things. So I squared is really what?
Negative 1.
Negative 1, and negative 2 times negative 1 really makes that be?
Positive 2.
Positive 2. And if I look at real of 2, what's real over here with this other stuff?
15.
All right, combining real with real gives me how much? 17. Real, real. Can I combine imaginaries together? You bet. How much imaginary do I have left? Negative 1. And that would be my answer. All right, so again, FOIL, first times first. So 3 times 5 was 15. Outside, 3 times negative 2i gave me a negative 6i. Inside, I times 5 gave me 5i. And last term, so I times negative 2i is a negative 2i squared. I squared was negative 1. We've learned that and used it. So negative 2 times negative 1 was positive 2. Positive 2 is real. 15 is real. They go together, become 17. Negative 6i, positive 5i go together and become a negative 1i. Real plus imaginary, in this case real minus imaginary. We get a complex number when we multiply. All right, good? That, in a nutshell, is what this section is about. Okay? But we do still have what we started with, which was solving complex numbers or solving our equations.